Hello, everyone. In this gizmo, the evolution, mutation, and selection gizmo, you'll be looking at the theory of evolution and, in particular, how mutation might play a role in driving evolution. So, before we get started, I am going on the left here, I'm going to show you some of the gizmo controls to familiarize you with the gizmo and where you can find certain things. So you will see that there here you'll find some insects and you can select each insect by clicking on said insect. And when you do, over here on the right hand side, you're going to find their genotype and phenotype listed right here. You can adjust the color sliders of the background here as well as the rate at which the insects might mutate. When you press play, you will find that the bugs pair up and then a bird comes and eats those offspring of each parent. So in each shaded area here as you're watching, the two that pair up are the parents, and the four insects to the right here are their offspring. So again, here we're going to find two parents, four offspring, and then the bird comes and eats the insects. That is all you really need to know to manipulate the gizmo. Now I'm going to go through the Gizmo guide and point out some questions that some students might find a little tricky to help you through the Gizmo. Make sure that when you're doing the Gizmo guide that you fill in each area completely. Take your time and do not get overwhelmed. If you take it step at a time, this will go quickly. So fill in the definitions, making sure that you use the scientific definition of those words. When you get to question 1 here, it asks you, which 6 alleles does the insect have? When I'm referring to the 6 alleles, you will see here under the genotype that there is chromosome 1 and chromosome 2. Each chromosome has 3 different alleles. So this insect's 6 different alleles would be WWR, WWW. So make sure that you fill in all 6 alleles for that question. Now, this gizmo is going to focus on the difference between a genotype and a phenotype, and it is important that you know the difference between those two. Again, referring to the gizmo, the genotype here says exactly which alleles this insect has. So this insect has a white allele, a red, white, white, white. So those are the different alleles it has for the way its color, the way it appears. However, how does it actually look is the phenotype. So when we look at that insect, we would say, well, it's kind of pink. An insect that would have an allele red, blue, red, red, blue, red, that's its genotype, RBR, RBR, but its phenotype, it might look a little purple. So this applies to all living organisms where your genotype is what is in your genes, and the phenotype is the way that it appears in the environment. This gizmo is going to ask you how mutations might affect a population. And we have to understand that when mutations are introduced into a population, it changes the genotype. It changes the alleles that are available to that population. That information will help you answer this question 4. For question 5 here, it is going to ask for you to gather the genotypes of a generation of parents and offspring. So you're going to have to pause the gizmo such that you can see all the parents and all 4 offspring. It is important for this set that you find a set of parents that has 4 completely different chromosomes. So you're going to have to check both parents to make sure that they have 4 completely different chromosomes. The example I give here is one you can see is the one has WWW and so forth. So they have to be 4 completely different. If you find, for instance, these aren't, there's 2 that are WWW, so we know that that's not going to work, then you're just going to have to play the sim longer until you get to a point at which you do find 2 insects that have 4 different chromosomes. And again, this one won't work because we can see that this insect has WWW and so does this one. So you just have to keep looking until you find a set of parents that has 4 different chromosomes. You're going to record the genotypes for those parents here and the genotypes for their offspring in this table. Make sure that you complete this part, which is labeling the offspring chromosomes A1, A2, B1, or B2 as they are listed up here. After you do some of this experimentation, you're going to have to answer some challenge questions. So this one says, mutation is one source of variation. It introduces new alleles to a population. What is a second source of variation? I would urge you to think about siblings for this question. If you have a sibling or if you know siblings, do they look exactly the same even though they have the same parents? Probably not. Why is that? Why don't they look exactly the same if they have the same parents? When you work through this gizmo, it's important that you understand the difference between physical fitness and fitness in terms of evolution. So it says, how does the fitness relate to the color of the insects? We are not talking in terms of evolution, we aren't speaking physical fitness. Fitness is how fit an organism is for its environment. So that does not mean it's fast or it's strong necessarily. It could be how camouflaged it is. When you are working on this table, you will find the average fitness of the generation here on the gizmo, and then you can calculate each individual fitness by clicking on each individual insect and it will give you their fitness here. So you're going to, the gizmo will explain, excuse me, the guide will explain as well, but that's where you find those values. Now, you should find that a pattern when you do this activity that points towards whether or not the fittest organisms survived. But we have to keep in mind that in natural selection, we can't guarantee any organism's survival. Even if it's the most fit organism, it's not guaranteed that that organism is going to survive. Chance things do happen. And then again, when you're filling out this table, remember that phenotype is asking for the red, green, and blue values found here. But remember back to what I've said, that phenotype also just refers to the way that the insect looks. So obviously, if the red color, the red number is higher, it has more red value and so forth. So I always remember that phenotype is the way that the organism looks. And then eventually you're going to get to these few questions at the end. They are a little bit more challenging, but if you do the gizmo, stick with it, really think about the process and evolution, fitness, the way that the mutations play into how an organism might be fit for its environment or not, you should be able to complete these with no problem. I hope this helps. If you need any additional help, do not hesitate to contact me.